All right, let's talk about building serverless apps with Go on AWS Lambda. This is a pretty cool combination, you know? You get the raw speed and amazing concurrency of Go, and you pair it with the just massive scale of serverless. So let's dive into what makes this pairing so unique and powerful.
Right out of the gate, we run into the most fascinating thing about Go on Lambda. It just doesn't work like Python or Node.js. And that brings us to this really core question. How in the world do you run it on Lambda if there's no dedicated Go runtime for it to use?
To get to the bottom of that, we really need to look at what sets Go apart in this whole serverless world.
So this slide here, this is the key. For something like Python, Lambda has to bundle your code with the Python runtime. But Go is different. It compiles down to a single native executable binary. It doesn't need a language interpreter. It just needs an operating system to run on. And that's exactly why we use what's called an OS-only runtime.
And speaking of that OS-only runtime, it is super important to know that the old Go 1.x managed runtime, well, it's a thing of the past. Nowadays, the modern way is to use these provided runtimes. They give you way better performance, smaller binaries, and support for awesome stuff like ARM64 with Graviton 2 processors.
Okay, so now that we get the why, let's break down the how. What does the code actually look like?
You know, a Go Lambda function looks a whole lot like any other standard Go program you'd write. You start with package main, you import your dependencies, like the official AWS Lambda Go package, then you define a handler function for all your business logic, we're calling it handle request here, and finally you create that all-important main function to kick everything off.
So, how does Lambda know which part of your code to run? Well, it all comes down to this one little line inside your main function, lambda.start. You just pass it the name of your handler function, in this case, handle request. That simple call is the magic handshake that connects the Lambda service to your specific piece of code.
Oh, and your handler can also take something called a context.context object. This thing is incredibly useful. It's this optional parameter that gives you a ton of metadata about the invocation, like the function name, memory limits, the request ID, all stuff that's absolutely essential for good logging or talking to other AWS services.
All right, let's switch gears to deployment. How do we get this thing running? We've got two main paths, and the first one is the classic, super lightweight zip archive.
Now, when you're using a zip file, there is one rule you absolutely, positively have to follow. Your compiled Go executable must be named Bootstrap. This isn't just a suggestion, it's the exact file name the Lambda service is looking for to start your function. No exceptions.
And this just lays out how simple the process is. First, you compile your Go code, but you have to specifically build it for a Linux environment. And make sure that output file is named Bootstrap. Then, you just zip up that one file. Make sure it's at the very top level of the archive, not buried in a folder. Finally, you just upload that zip to Lambda. It's a really clean and direct process.
The second path gives you a whole lot more control and flexibility, and that's by packaging your function up as a container image. And here, you've got a choice. You can use an official, highly optimized OS-only base image from AWS, which is definitely the recommended way to go. Or, if you need some special tools or a different environment, you can use pretty much any other base image like Alpine or Debian. You'll just need to add a small piece called the Lambda Runtime Interface Client to handle the communication for you.
And really, no matter which base image you pick, efficiency is everything. Following best practices for writing your Docker files is just critical for keeping those images small and making sure your function's cold start performance is as fast as possible.
And here's a pro tip for you. One of the absolute best practices is the multi-stage build. You use one container stage that has the full Go toolkit to compile your code, and then you copy only that final single binary into a second super minimal stage. This slashes the size of your final image, and that can make a huge difference in your cold start times.
So, we know how to build and deploy. Now let's just quickly run through a few key best practices for writing Go functions that are clean, efficient, and easy to maintain.
First step, design your code so you can actually test it. Think of your handle request function as just a thin wrapper, a translator. Its only job is to turn the Lambda event into something your main business logic can work with. If you do this, you can unit test all your core logic without ever needing to pretend you're in a full Lambda environment. It's a game changer.
Second, you gotta optimize for performance. Lambda loves to reuse execution environments for back-to-back invocations. So by setting up things like your AWS SDK clients or database connections globally, or maybe in an init function, you only do that heavy lifting once. Every call after that is going to be way faster. And third, keep your function flexible. Please, never hard code things like bucket names or database credentials. Pass them in as environment variables instead. This makes your function so much more portable. You can deploy the exact same code to dev, staging, and production just by changing the configuration.
So when you put all of this together, the benefit is crystal clear. Go on AWS Lambda gives you the insane performance and tiny size of a compiled binary, but with the massive scale and pay-as-you-go model of serverless. It really is a powerful combination for building modern apps.
The whole approach just strips away the need for a language runtime, letting you focus on pure compiled performance. So the real question now is, with all this speed and efficiency at your fingertips, what are you going to build?